Good day, Professor. This is Group 9. We're going to be presenting our topic Info 5. So our topic is comparing automated medical diagnosis using traditional convolutional neural networks or modern transformer models. So basically, we're seeing if transformer models, which have done so well in NLPs, can they take over CNNs for medical imaging and diagnosis, and if they can actually even do better. The innovation behind this project is because recent advancements in deep learning techniques, particularly the emergence of transformer models, have raised a lot of questions on potential use cases in image classification, which has so far been dominated by CNNs. They've noticed a lot that in industry, medical images and data have actually been used to help identify conditions from different mammographs, and CNN has helped a lot and shown a lot of success in image analysis, and have long limitations in processing long data sequences, whereas transformer models have actually excelled in NLPs. And because of that, we see, is it possible for them to even produce even better relationships in medical diagnosis? And the research question here basically is comparing the effectiveness of traditional convolutional neural networks and the modern counterpart, which is the transformer models in automated medical diagnosis. So where we're going to be investing the accuracy, or the more or less like the F1 score, the efficiency and the interpretability of both models. The purpose of this project is to help determine which type of deep learning model is best suited for real-world applications in the field of medical diagnosis. The purpose of this project is to compare the effectiveness of traditional convolutional neural network CNNs and modern transformer models in automated medical diagnosis, aiming to investigate and compare accuracy, efficiency, and interpretability of models, which we've said. The background of study, what has been done so far, basically in the field, we've seen people trying, people who have used CNNs well over time. And with the recent emergence of transformer models, which has been very promising, we want to see if this can be used in medical diagnosis. Automated medical diagnosis is a complex task which requires analysis of different images and data to identify potential health conditions. So this study is going to help us to see how effective traditional CNNs are compared to most of the typical transformer models that we already have in store, and if this can actually be used eventually in our analysis. The methodology that we're going to be carrying out, we're going to be using cancer, we're going to be considering cancerous cells, and we want to look at the cancer imaging archive. So because we are not going to be, we need to streamline ourselves to a particular disease and see how we can identify that particular imaging. We'll first identify that using image data. So on the TCIA, there is like an open source which provides researchers with an access to a large collection of medical images. And then we're going to split the data into training, validation, and testing sets. On the TCIA, it's already classified as cancer or not cancer. And then we will create a baseline CNN model based on what has been done in to be specific, Shahabuddin's work in 2019. So we are going to split the data, create a baseline model based on that work, which was about 90+% accurate and had a very high F1 score. We're also going to be fine-tuning the model just to make sure that we get the best of the best in the cancer image for the CNN. Just seeing how best we can get the model up to. And then we'll implement the transformer model and compare its performance with that of the CNN using evaluation metrics, using interpretability, like precision and F1 score. And we'll see how interpretable both models are. So that's going to be what we're going to do. So the limitation of this project basically is the quality of the image data obtained from TCIA can actually significantly vary because they are collected from different data sources, and the availability of since we're considering breast cancer, it's a wild field that there's a lot of work done, but taking this outside the use case of breast cancer, which like skin cancer and things like that, it might not be able to generalize well on those findings yet. So it's one of the limitations of this work. So another thing is the choice of deep learning models, or the choice of my transformer models basically might actually do affect the results, because this is a new field that we're exploring. And another thing too is the interpretation of the results may be challenging, especially when it comes to identifying specific features that models can use to make their prediction. Um, so the expected results is we're expecting that transformer models should actually do better than CNN models. And if it doesn't, we know that we can still, there's still room for improvements in either a model accuracy or in transformer models itself, to be able to incorporate what it's in traditional CNN models to also work well for for data like this. That's it. Thank you very much.